Now let us see how to find the derivatives of inverse functions. That is, let's consider that y is an invertible function of x. That means we can also write x in terms of y, which will be the inverse function of y. So in that case, suppose we want to find the derivative of y with respect to x, then that is given by dy by dx equal to 1 upon dx by dy. So in other words, it means that if we want to find the derivative of an inverse function, that is same as the reciprocal of the derivative of x with respect to y, right? So that is the simple rule to calculate the derivative of inverse function. The reason we do this is because like many times this dx by dy would be very easy to calculate. Okay, so we calculate that first and then take its reciprocal, which gives us the value of dy by dx. Alright. Now as a special case, let us take the category of inverse trigonometric functions and let us see how we can find out the derivative of that. So here I have taken the example of sine inverse x, and we know that x must belong to closed interval -1 to 1 and y, which is nothing but the range or what we call as principal value branch of sine inverse, is the closed interval from -π/2 to π/2. Right? Now our aim is to find out dy by dx, okay, and we don't know how to differentiate sine inverse of x. Right? So to do that, what do is we bring sine to the left hand side. So that means sine y equal to x, right? Now just for the sake of simplicity, let me write it in the other way around, that is x is equal to sine y. Now here if we visualize x as the function of y, then definitely it's a very straightforward function, and suppose we want to differentiate x with respect to y, that is dx by dy. On the right hand side, the derivative of sine y is simply cos y, as we already know. So therefore we get dx by dy as cos y. But we had originally started to find the derivative of y with respect to x, and hence using the formula that we just saw, the derivative of inverse function is given by 1 upon derivative of x with respect to y, right? So therefore here we get 1 upon dx by dy is cos y. Now we often try to write the final expression in terms of x, isn't it? So although 1 upon cos y is correct, if you want to write it in terms of x, then we have to observe that x was nothing but sine y. So the cos y which we have obtained at last step can be equivalently written as root of 1 minus sine square y, isn't it? And hence we can now replace sine square y with x square, because that is what x was. So therefore in this way we get the derivative of y with respect to x. Right? Now one thing to keep in mind, that if we consider the square root which we have obtained at the end, you may wonder that whether it should be taken as plus or minus, because you know the square root might have two values as we typically do in algebra. But here, since it's a function, we must consider a one value. And what is that value? For that, let us look at cos y, right? If we see y belongs to the interval -π/2 to π/2, so that means it must be in either first quadrant or fourth quadrant, right? So if y is the angle in either first quadrant or fourth quadrant, its cosine component must be a positive number, isn't it? So therefore cos y must be positive. So therefore the value of the square root must be taken as positive value only. Okay, so that is the point which we have to keep in mind.